So Prashasti is preparing for DRDO Scientist C and she has prepared the subject data structures and algorithms. So let's start, Prashasti. What is a data structure?
Data structure is it's a structure which organizes, manages, and helps in modifying the data in a computer system. For example, arrays or a linked list or trees. These structures help manage the system to store and modify and manage the data.
Okay, how are linked list, trees and arrays are different?
Linked list and arrays are linear data structures, whereas trees and graphs are non-linear data structure. And when I say linear, I mean that arrays and linked lists have been allocated memory contiguously. Okay, not linked list, but they are in an order. Whereas in trees, there is no order. So that's why they are non-linear data structure. And there are other major differences as well in between array, linked list, and trees.
Okay, if there is no order in trees, how do we traverse the data in a tree?
For example, let's say I have a tree A, B, let's say I have a binary tree A at the root, then B, C, and B, I have a child D. So every parent which has an index I has two children in a binary tree. One is I 2 of I, and other one is 2 of I plus 1. So like that, we arrange them in an array or any other using any other data structure like that. We arrange them in the memory so that we can access them.
Okay, so my question was that why are they called non-linear data structure?
They follow hierarchical structure. Like they don't follow, for example, in array, we have an object at location 2000. The next object according to whatever data type we are using. For example, let's say we are using a character, one byte for each. So after 2000, there will be 2001, then 2002, like that. We have an order. In trees, we have a hierarchical data structure, like just like the shape of a tree says it. I plus 2I plus 1, and after 2I there is 4I and 4I plus 1, like that.
Okay, what are the graph traversal techniques?
There are majorly two graph traversal techniques, PFS, sorry, graph traversals, right?
Hmm.
Three pre-order, post-order, and in-order traversals. In order traversal, we first access the left node, then we access the root node, and then traversal, not access, left, root, and then right. And in pre-order, we first traverse through root, then left and right, and then post-order, we go through left, right, and then root node.
And BFS and DFS is used for?
Those are search techniques, breadth first search and depth first search. Breadth first search goes through breadth. Like, as I said, first root is traverse. For example, we are searching an element in a tree and we are using BFS. So first we'll check at the root, then we'll look at the children, whatever children that a particular node is having. Then going to the left or going to anyone, like different searches and all. But in BFS, we'll go to the left child first, then its children, then right child, its children. Whereas in depth first search, we go to the leftmost child, starting from the root, of course. For example, a root is I, then we go to 2I, 4I, then 8I, like that. We go to the leftmost child. Then the leftmost child's sibling, like that. We traverse in a straight manner, deep in depth.
Prashasti, like what do we search out of BFS? Like what do we search with
We
these
can search a
algorithms?
no we can search nodes or element that are present in a tree.
Okay, in our tree.
Yeah.
And graph traversal techniques are in order. And then how do we traverse a tree?
I think I'm not sure.
Okay. So what all have you studied in algorithms?
I have gone through basic algorithms, like sorting algorithms, quick sort, mud sort, and time complexities like that.
Okay. What's the difference between quicksort and mergesort?
Um, in quick sort, we choose a pivot element. We set the pivot element to its right position in ascending or descending, whatever order we are going to sort. Then uh, that pivot element divides the list into two parts, not necessarily equal, of course. And in those two lists or those two sub lists, we apply the quick sort again. That means we are going to choose the pivot element again. And like that, we'll sort the whole list. Whereas in merge sort, we divide the list into two equal parts, the left side and the right side, then again, two equal parts like that.
Okay. How do you choose a pivot element in quicksort?
Sure. There are so many ways. We can choose the first element as the pivot. We can choose the last element, a middle element. But the most efficient way is choosing a random pivot using a random function. Why is it best is because when we are using other elements like start, first, or middle, there is a chance of always, like most of the times, getting O(n) square complexity. Whereas when we are choosing randomized element, random element as pivot, it's very rare that every time an element is chosen which gives the worst complexity.
Okay. When does the quicksort gives the worst complexity?
Okay, if for example, if the pivot element chosen is the start of the list, for example, the list is 1, 2, 3, 4, 5, and 1 we have chosen as the pivot element. So it will divide the list into 1 and n minus 1 elements. Then let's say we chose 2 as our next pivot element. Then it will again divide into 1 and n minus 2 elements. Like that, it will always be dividing like that if we chose the first element in an already sorted list. So that will give the worst case time complexity.
Okay. Do you mean that if the array is already sorted, then the
Yes,
quicksort will give the worst time? Okay. Any
yes,
other
ma'am.
case in which quicksort will give the worst time complexity?
Um, Not sure.
Okay. And what is the average time complexity of quicksort?
N log n, order of n log n.
Okay. And the merge sort?
Merge sort is n log n inverse best and average time complexity. Order of n log n.
Okay. So other than sorting algorithms, what do you know about dynamic programming?
Dynamic programming uses, okay, if a problem is given to us and what dynamic programming does it solves the problem from top. It sees a big problem, it divides into smaller chunks, which are somewhere correlatable. Then, if they are further dividable, it further divides it and goes until the smallest chunk of problem is available, if possible, in a unit or constant time, and solves it.
Uh, what are the two conditions for the dynamic programming that we can apply?
The first one is overlapping structure, and the other one is optimal substructure. Uh, by optimal substructure, we mean that every problem has an optimal solution. We try in dynamic programming tries to solve every sub problem, every subproblem has an optimal solution. And by overlapping subproblems, we mean that, for example, we have Fibonacci numbers. So in Fibonacci numbers, what we do is we sum the previous two elements. So if we use regular recursion, we have to solve or we have to calculate every time the previous two elements. But when we use dynamic programming, what we do is we save the values of it so that we don't have to do it again and again. And that again and again procedure is overlapping. That means we are solving a calculation or we are solving a small chunk of problem again and again. So these are the two basic things, overlapping problem and optimal substructure.
Okay, how do we solve dynamic programming?
Um, We use memoization or tabulation. We divide the problem into smaller chunks and try to find the optimal solution for every smaller problem. And for overlapping conditions, we use a table or a memoization technique to store the mostly calculated values.
Okay, what is the difference between greedy algorithms and dynamic programming?
Okay, greedy algorithms doesn't always return an optimal solution. They might give you an optimal solution, of course, but it is not necessary that they will give you an optimal solution. Dynamic programming gives you a set of solutions, whereas greedy programming just returns you one that fits the best. Uh, no matter, it could be an increasing problem or a decreasing problem, whatever we want to increase the cost or we want to minimize the cost, that will choose the best option available at that moment of time, while as dynamic programming tries to see the future or the next outcome of it and tries to give you the optimal answer for that or optimal solution for that.
Okay, so Prashasti, let's come to the feedback. Okay,
Okay.
uh, first I'll tell about algorithms. Okay, one question I asked that what is the worst case of quicksort? So it is like when all array is already sorted or the elements are having say like all elements are same
Right.
or
Yes,
equal.
yes, ma'am.
Okay, so this is the worst case. And other than that, I felt that your algorithms is strong.
Okay.
So you need to revise little bit, but I think it's quite strong. The answers that you gave were very good. But the data
Mm.
structures part, you got quite confused.
Hmm.
Especially when I asked you the graph traversal techniques in which you told pre-order, in order, and post-order.
Uh-huh.
It should be BFS and DFS.
Yes,
And then
ma'am.
I asked then what is the tree traversal, and then you were like, I don't know. So you got slightly confused in tree and graph, so you can revise more on that. But I think your algorithms is quite strong. You can revise more. Okay.
Okay. Thank you so much, ma'am.